Okay, good morning. Today's lesson is still on Newton-Raphson method. I'm going to take this question number 6 from checkpoint 12.3 from your textbook. Right? You are to show graphically that the equation given here, e to the minus 2x equals to 5 plus 4x, has only one real root and it lies between negative 1 and 0. By taking initial guess or x0 equals to negative 1, you want to use Newton-Raphson method to estimate the root correct to 2 decimal places. So there are two tasks here. Okay, first you have to show graphically where the root is, and then secondly you want to find the root using Newton-Raphson method. Alright, so the function is e negative 2x, right, equals to 5 plus 4x. So graphically, that means we have to draw the graph. Alright, excuse my graph here. You should have a better looking one. Okay, here's your exponential graph, right? Label your graph. Okay, y e negative 2x. Okay, label your axis, and then you have one more linear graph, okay, with 4x, with positive 4 as a gradient. Okay, let's try that. Okay, should be linear. Use your ruler. Okay, here we have an intersection point of 1, and here the intersection point is 5. Alright, and the the x-intercept here is negative 5 over 4. Label your graph. Y is 5 plus 4x. Alright, okay, so now what do you see from the graph? Okay, that there is one root here. Okay, now the location of the root is between negative 5 over 4 and 0. So what we have shown here graphically, we have shown that there is only one root, and the root lies between negative 5 over 4 and 0. Not quite what the question asked, right? Okay, since the question asks you to show that the root lies between negative 1, this is what the question wants, between negative 1 and 0. So graphically we are unable to show that, but we can show that the root is in fact between negative 1 and 0 if we use IVT, right? So IVT, we're gonna take our function, substitute minus 1 in it, and take the same function, substitute 0 in it, right? So if it's negative 1, means you will have, what is fx? Fx is, what is fx? Fx is e negative 2x, right, minus 5, alright, and minus 4x. This is our fx, right? So you substitute negative 1 inside it. You have negative e to the power of 2 minus 5 minus or plus 4, right? Okay, and if you substitute 0 in it, e to the power of 0 is 1 minus 5 minus 0. Okay, so you see the value. 1 is positive, e square is about 9 something or 10 something, minus 5 plus 4, that's positive. Alright, while f of 0 is negative. Okay, so there is absolutely a sign change there. Okay, sign of fx changes, right? Changes between negative 1 and x net 0. So your conclusion, root is in the interval of, okay, if I write just like this, interval of negative 1, 0. Okay, is that clear? Now the next task, okay, the next task is to use Newton-Raphson method. Yeah, Newton-Raphson method to find the root. Okay, so we're gonna write our fx again. Fx is e negative 2x minus 4x minus 5. Differentiate that. Okay, in Newton-Raphson we need differentiation. In the formula we're going to use the differentiation. Minus 2e negative 2x minus 4. Alright, and the question asks you to use x naught as 1. Right, okay, so by taking x naught as 1, then estimate for the first estimate will be x1 is take x naught minus f of x naught divided by f prime of x naught. Right, so essentially you want to key in your calculator, save 1 as your answer, and then you key in, okay, if x naught is 1, that means answer minus, okay, exponential of 2 times your answer, right, minus 4 times your answer, minus 5, all this get divided by minus 2e, right, to the exponential, minus 2 times exponential of answer. 2 answer. Is it 2 answer? Yeah. X naught. Answer minus 4. Alright. Then the answer that your calculator should give you is negative 0.6. Okay, rounded off to 3 decimal points, 660. Okay, 3 decimal points. Yeah, your final answer is in 2 decimal points, so you're going to keep 3 decimal point in your solution. Okay, so here I want to erase this. Okay, then I'm gonna write this as answer. Wait, where is it? Oh, sorry. Okay, into what is here? Right, so this is answer. Answer exponential to. Okay. Alright. Then, okay, going on to the second iteration. Okay, you do the same thing. Now you just click the equal sign in your calculator. Okay, x sub 2 will give you negative 0.540. x3 is negative 0.529. Okay, I hope you're getting the same numbers here. x4 is negative 0.529. As you can see, x3 and x4 doesn't change, yeah? Okay, that means we can make our conclusion, right? The root that we're looking for in 2 decimal point is negative 0.523. Decimal point. Okay, now this. Alright, I hope I make that clear.